Geometry, how's it going? It's week 5, it's assignment 1, it is 5.1. We're going to finish up talking about our trigonometric ratios with the last one, cosine. I thought this meme would be relevant now that we know how to make sure that our calculators are in degree mode and not radian mode, alright? I got another meme. I was looking at memes and I'm like, oh, I literally laughed out loud. Ha ha. Okay, so reminder, we're going to start talking about cosine. So a trigonometric ratio is a ratio between two sides of a right triangle. So we talked about sine. The sine ratio, I'm going to just say sine of an angle theta, was the ratio between opposite over the hypotenuse. All right. Tangent was the first one we talked about. Tangent of the angle theta. Tangent was opposite. Again, I'm just following from this little mnemonic device, I guess you could say, opposite over adjacent. The last one we're talking about, I'm going to put in a different color. Cosine here. So cosine of an angle is adjacent. It's this ratio between the adjacent side and the hypotenuse of a right triangle, all right? So this thing of SOHCAHTOA, again, that's what helps me remember them. So maybe you want to write that down, commit it to memory. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Say it 5 times fast, I don't know. So here we go, just a real quick recap of the cosine ratio. So I've got cosine of an angle theta. I'm just going to pick a reference angle in this triangle. We're going to go with that one there. Cosine of an angle, again, is adjacent over hypotenuse. Let's label all of the sides real quick. So if you're taking this angle as your reference angle, this side over here would be the side that is opposite. Your hypotenuse is the side that is opposite of the right angle. So that's the hypotenuse. And then the adjacent side is the side that is next to the angle that is not the hypotenuse. All right, so this last one down here is your adjacent side. Again, cosine, SOHCAHTOA, all right? So cosine of an angle is adjacent over the hypotenuse, okay? Adjacent over the hypotenuse. Let's put this to some numbers. All right, so here's some cosine ratio examples. Woohoo! So, looking at this first one here, cosine of an angle. Or cosine of an angle, again, is, I'm just going to write it all out like we usually do. It's adjacent over hypotenuse. So, can I identify the adjacent side to this angle theta? Here's my angle, all right? Here's two sides that make up theta, and the adjacent side is the one that is not the hypotenuse. So my adjacent is 20. My hypotenuse, again, is the side that's opposite of my right angle. It has to be 101. So cosine of this theta angle here, we could just say is this ratio of 20 over 101. I mean, you could even plug that into your calculator and see what decimal it gets. I'm just going to leave it here in fraction mode, which is pretty simple. Okay. Cosine of theta in this triangle. Again, cosine of an angle. Adjacent over hypotenuse. So my adjacent side, again, the side that like makes up this reference angle that is not the hypotenuse, well, that has to be my 15. 15 over my hypotenuse. Again, the hypotenuse is the side that is opposite of your right angle, or it's the longest side in your right triangle. So 17 is my longest length. There has to be my hypotenuse of 17. All right, so there's my ratio. Cosine of theta equals 15 over 17. This next one, cosine of theta again, just so we hear it one more time. Adjacent over hypotenuse. My adjacent side is going to be that 55. The hypotenuse, my longest length, the side that is opposite of my right angle, is the 73. And there is my ratio there. Let's move on to an example. All right, I'm kind of going quick through these, but these are all things that we've kind of done. Now we're just putting a new name to it, right? So this one here, I want you to solve for the length of the hypotenuse, and then I'm throwing in a little challenge question, and I'm asking what would the perimeter of the triangle be? So let's just focus on part A for now. Basically what we want to do is set up a cosine equation, and then we can just solve for a variable. So I'm going to say cosine of, and here we actually know the measurement of our reference angle, theta. Our measurement is 41 degrees. So cosine of 41 degrees, this ratio, it has to be this ratio of, again, our adjacent over our hypotenuse. And here we know the adjacent side is 18, so I'm going to plug that into my equation now. I'm just taking the step by step and saying cosine of 41 degrees is equal to 18 over x. Now just solve for x. So I'm going to get x out of the denominator. I'm going to multiply by x on both sides. Multiply by x on both sides. All right, and that gets me x times cosine of 41 degrees equals 18. And then I'm just going to divide by cosine of 41 degrees on both sides. That's not 410, that's 41 degrees. All right, so that cancels out, and then I have x equals 18 over cosine of 41 degrees. If you plug in cosine of 40, can I say that 5 more times? If you plug in cosine of 41 degrees into your calculator, making sure that it is in degree mode, you will get a decimal of 0.75470958, yada, yada, yada. It keeps going. 18 divided by that number gets me x equals 23.850. Again, that number just keeps going on. So I'm just going to round it roughly to 23.9. All right. So in that process, we were able to set up a cosine equation. We were able to solve for a missing length in that ratio. We now know that the hypotenuse is 23.9 feet. Maybe this is in feet. All right. Part B is now asking, what is the perimeter of the triangle? I'm going to real quick say, now I know what x is, so I'm just going to replace that with 23.9. The perimeter, if you remember, perimeter is the distance all the way around your triangle, right? Maybe this is like asking about if you had to buy fencing or something. So basically we just need to figure out what this third side length is, then we can add it all together. We'll have a perimeter, all right? So how do we find x? Well, this thing is a right triangle. What could we use on right triangles? The Pythagorean theorem. So set up a squared plus b squared equals c squared. Here's my legs of my right triangle, so I know that. X squared plus 18 squared has to be equal to my hypotenuse squared, 23.9 squared. And now it's just solving for x, because that's my last side length that I need to know. So 18 squared is 324. 23.9 squared is 571.21. Again, I just did this all on my calculator. Subtract 324 from both sides, and I got x squared equals 247.21. And then to get x by itself, I have to square root both sides to cancel out that square. And then I just get x equals, I got a value of 7222913. I think I wrote it down wrong. 72291. Anyway, it just keeps going on and on and on. So I'm just going to round that off about 15.7 feet or so, right? All right. We know one side length of 18. We just solved for another side length of 15.7. And we just found that our hypotenuse was 23.9. Add those all together to find your perimeter. And I got a perimeter of 57.6. All right. So if you've got a right triangle and you're asking for perimeter, and you know maybe some information about an angle and a side, you could use some trigonometric ratios in order to solve for all the other sides, which I think is pretty darn cool. Anyway, let me know if you have any questions. I've got a couple that are going to go with this last cosine ratio lesson, I'm thinking the next assignment we're going to cover the inverse of cosine and sine, because we talked about inverse of tangent last week, or the week before, I can't remember. So we're going to cover the inverse of sine and cosine, and then we're going to just see where we go from there. I might do a little bit more trigonometry. We got some fun stuff. I think this is pretty cool. Have a great day. Bye. Go team. Woo!